A few housekeeping items on today's webinar. Everybody is muted, and your video is also muted. But if you have questions with regards to this webinar, regarding any of the items that Tony will be talking about, if you just put them in the Q&A section, then at the end of the session we will save a little bit of time to go through that Q&A portion of the presentation. I'd like to do just a little bit of promoting here for Lucas. Last month we touched on the subject of exchange heavy-duty injectors, and I'd like to let you know we have a variety of all of these heavy-duty injectors now available. So if you need something, please contact us. I don't know if you knew this or not, but we also have a good array of turbochargers. And the nice thing about it is you do not have to return the core to us. So that's a plus. In addition to that, just released, I believe it was last week, is electronic valves. And these flow and pressure control valves are for the common rail pump. And the applications are Denso, Bosch, BDO, etc. Also like to put a little plug in here for test equipment. We have a variety of different pieces of test equipment and tools available to do an array of products in the diesel fuel injection line of components. So anybody interested in this, please let us know or contact us, and we can send you a brochure, give you some pricing, let you know what they're for, and how you can go about that. In addition, Lucas will be at Apex and SEMA this year. So as we are only 2 months away, I thought give a little promo here to Lucas being at the Apex website at the Apex show, and we'll be at booth A1081. Okay, like I said just a little bit earlier on, here's some contact information for either Erica, Ricardo, or myself. And as I said, if you have any comments or suggestions for these monthly presentations, I really, really would appreciate some feedback. So either give me a call, or if not, send me an email. That would be greatly appreciated. Okay. Our presenter this afternoon, as most of you know who have been with us for the last several months, is Tony Salas. And Tony is a veteran technician and instructor on light-duty diesel systems. He runs his own professional shop in Las Vegas and training company also in the heart of Las Vegas, and he's an instructor for the company called Powertrain Training. The title to the presentation this morning is PowerStroke 6.0 Diesel Review. So without further ado, Tony, I'll hand it over to you. Thank you, Tony.
All right. Thank you very much, Mr. David. Yeah, we like to get your feedback because obviously we want to know what you're looking for, what actually will help you, will work best for you. So in this case, we'll definitely try to accommodate that in any which way. So yeah, we all would like to see different views of terms of technical training. So in this case, yeah, please let David and Erica know what you got going on. So now we need to switch over to my presentation now. So let's go ahead and switch over. I need you to switch over so I can get my presentation up. So hopefully, do you want to continue to, yes, give me a second. I'm trying to go back to my presentation there. So all right, everybody should see my presentation. Good morning, good afternoon to many of you. The topic of the day is an old dog. The old dog is, yes, the 6.0 PowerStroke. And one of the things I said in my roundtable yesterday was I was taking on a 6-liter that same day. So turns out that I'm really fresh in the head with the 6.0. Many of you probably know that the 6-liter has been pretty much still around. I guess what I'm trying to say is, as I visited shops throughout this last 5 months, I've been doing a little bit of traveling. It's funny how the 6-liter still is there, so it's still one of your money makers. And some of them are pretty simple. Some of you are very veteran about it, but some of the people that I talk to, not so good at it. So, so depending on where you're at with 6-liter, we're going to talk about the overview of the system itself, the G2 injector, maybe a little bit about VGT turbos, The engine design, common failures, service information. I'm going to hit hard on some service wiring diagrams and obviously your diagnosis. So what do we still see in the shops today? Drivability issues, and they could be an array of stuff. As it ages, there's going to be more symptoms. But I got to tell you something. One of the main things I find when I work on 6 liters is the fact that we're repairing other technicians' errors. And what I mean by that is we got to quit being mean to the wiring harness and connectors. I see guys pulling intakes, pulling stuff, and you're tugging and pulling on harnesses. And if you're aware, Ford no longer has some engine harnesses for the 0304s. So therefore, we're running out of parts sometimes when it comes to engine harness. So we got to do a lot of wiring repair. So with that said, what that leads us to a lot of intermittent drivability issues. So we got obviously the engine issues, we got cylinder heads, the head gasket, pressurization of the cooling system. We still see the diesel fuel in the coolant, the high pressure ICP. We still see that. I had one earlier this few months ago that actually was kind of kicking my butt in a way because I had an ICP pressure, but it actually dropped the pressure when I actually reconnected the IPR and the injectors, so that was an interesting one. Low engine oil pressure loss still happens. You still see the needle bearings failure from the lifters. We also see boost issues, and probably the biggest one is modified programs out there. So if the truck has been deleted in any which way, where they're taking out the EGR, whatever it is, we see a lot of poor quality, very poor quality tunes that are sold on tuners today. So obviously the one that's been knocking on my door a lot when it comes to phone calls and issues that I see is pretty much the issue where you got no communication, or you got something causing no communication, or no crank, no start. As you know, the 6 liter has the PCM bolted there on the passenger side on these trucks, primarily the Super Duty and cab chassis. In this case, you're going to notice there's two 46-pin connectors. And if you look at the slide here, you're going to notice there is the engine harness connector, and then there's the body harness connector. So the body harness connector is all body functions, and the engine connector is pretty much everything related to engines. So when this vehicle was assembled, the engine harness, as you may have or may have not done any cab off repair, you probably have disconnected these connectors. Now, if you look at the picture here, you're going to see, the front of the vehicle's to the right, and to the left would be towards the bulkhead or the firewall. And in this case, it goes as follows. We got the body connector first from left to right, and then with the middle connector is the easy one. That is your engine connector. Many of you know that. Well, the engine connector, like I said, is housing a lot of different things. So we have learned our lessons with the 6 liter through time. And one of the things is that if I ever get a no communication situation, one of the easiest things to do is to literally disconnect that engine connector. Just pull it off and see if now the scan tool does communicate. So the scan tool will power up, but it just will not communicate with the PCM. Another thing we have seen is no crank, no start. So in this case, you can manually override over on the passenger side, run that red cable to the positive terminal, and that'll crank the engine. But if it cranks and you know that the starter circuit's fine, a quick check you can also do is to remove that middle engine connector and see if it now cranks. It won't start, but at least you will know that it'll crank with the key, because your problem is no crank, no start. So in this case, that means what? That we have an issue in the wiring harness in the engine connector. Now, I'm going to be honest with you, I could tell you stories and stories about issues that I've had with this in the past, but one of the key issues is the problem in the engine harness, or is the problem in any of the actuators that you actually have a backfeeding effect, where we're seeing voltage being plumbed back through a certain circuit, and that actually will tend to shut down the module. Now, in my experience, it's never hurt the module itself, the PCM, but it has caused no communication and not enable any kind of cranking condition to get the engine started. Now, I'll give you the customary culprits. They've been the IPR shorted solenoid, they've been the glow plug control module, and we've also seen the ICP sensor also do the same thing. So, but obviously there's further diagnostics you're going to have to do here as well. Now, when you look at the service information, please note that the service manual is giving you good information. I like to use anything that has access to Ford Service Info. Ideally, I like to use Identifix. You can find this on your Identifix. Not only, it's also your old data and your pro demands out there. That'll work too as well. But your connector envy, we call it, there's your body connector. And one of the key things I like to hit and diagnose on is when I get a 6 liter, you got to understand the truck I worked on yesterday, for example, had 311,000 miles. So there's been a lot of use and abuse on this poor truck, and who else has touched it as well. So when you're dealing with that kind of truck and has been used, please note, we have to do some, preliminary checks when we have a drivability problem after I've done my basics. Obviously, I've done some basics, right? Now, if it comes down to any PCM related issue or drivability issue, I understand that, there's relays and fuses that power up this thing, they're grounds, and I don't know pretty much their identity. In other words, how are they doing? So when we teach electrical, we talk about this thing doing voltage drop testing. And when I do voltage drop testing, I tell guys, and they just don't know how to read the connector in view. For example, if you look right here very closely, you're going to see that under pin 10 and 11, we're going to see a case ground and a power ground right there. Now, what is the difference between a case ground and a power ground, you would ask, right? Well, a case ground, the name says it all. It goes to the chassis, or in this case, to any framework of the vehicle, while a power ground actually goes to the battery terminal, exactly to the battery terminal. So that's the difference. So pin 10 and 11, we can clearly see that we're going to, you know, grounds. So in this case, whether being the case or whether being the negative terminal of the battery. So then on pin 23 here, hopefully you can see it on the screen, you'll be able to see another power ground. So right off the bat, off this body connector, that's where we're at. We're off this body connector, not the engine connector. On the body connector, we can see the 3 grounds. So now let me step back again to the earlier connector because this is a 46 terminal 46 pin connector. So if I look closely between 1 and 13, as you can see on the screen, there is battery voltage, but these are for different things. For example, that pin 2 ACCR is for the air conditioner clutch relay control. You're going to see battery power here at the ACCS, which is your AC cycling pressure switch. And another one, the PTO. If equipped with a PTO, we'll see that's a PTO setup. So that's not power or positive potential that's being applied to the actual computer. So as I scroll along here, you're going to see the grounds we just saw, but then we're going to see a pin 23 ground right there. But I'm looking for battery power. There's nothing there. I keep going down the list to the 46 pins, and at pin 34, I'm going to go ahead and see that I got pretty much battery voltage right there. There's my V power, pin 34, if you can see that right there. Then as I scroll down the list, I go up. I'm going to do it manually here by blowing it up. We're going to see that we have to have some kind of keep alive power. There's your pin 40. And then on 46, there's your V power. Now, why am I showing you this? Well, first of all, we realize that we have 3 grounds that feed ground to the computer negative potential. And then we have 3 positive potentials or 3 powers going to the, to the computer. So 3 powers, 3 grounds, right? So when we look at the wiring diagram, you're going to be able to see those same guys right there. So therefore, as I use my highlighter here, we're going to go ahead and see that we got, there's my battery power right there. There's my other 2 V powers there. And then there's your 3 grounds down here, because it's essential for you to do a voltage drop test to make sure that you actually have battery voltage and you have ground. So yeah, you can do the standard measurement where you disconnect and you do the voltage checks, but the thing is you got to back probe. And yes, you literally have to back probe. So to actually do what is the actual voltage drop there. So if I am dropping voltage, I'm going to have a problem. So again, got to verify battery voltage and ground, because one thing is to test the circuit open. Another thing is to test the circuit closed. In other words, connected with key on. So that's what you want to be doing. So in essence, that's important for you to understand. And you'll notice that on this pin 46 right here, I'm going to circle this guy right there. We're going to notice that that is getting power through the relay as well. So then that also goes to pin 34 as well, but there's the relay. So a common thing we see with these aging Fords, along with the 7.3s and the 6.0s, we tend to look at the PCM power relays because we could have a low voltage caused by not just a bad ground, but also by a bad relay itself. So the relay can be bad, meaning that the contacts of the relay can be, worn and torn, which will cause intermittent problems and maybe possible voltage related diagnostic trouble codes to be set. So it's important to keep that in mind when you diagnose there. Okay, very important. So hopefully that'll help you there. So obviously, if you got no crank, no start, like I said already, that number 2 right there, got to disconnect it. So like I mentioned earlier, it is essential for you to test to make sure the starter does work. So because I can't tell you how many customers we've had in the past where you got no crank, no start, and it has nothing to do with the whole computer. It's the fact that somebody cranked and cranked and cranked and cranked and cranked and literally killed the starter. So therefore the starter is just, no longer operational. So I'm sure a lot of you know that many people used to upgrade to the 6.4 starter. You can actually install it's bolt-on, no modification needed. to actually put in a 6.4 starter, while the 6.7, some people are going with the 6.7 starter on the 6.0s, but I believe, I've never done it, I'll be honest with you, but I believe you have to change a bolt size on one. So therefore, you can do whatever you want, but a lot of guys are not going, a lot of, people that work in this trade are not going back to the 6.0 style starter. They're going over to a 6.4 starter, or if not, the 6.7 starter as well. All right. So quick word to, quick tip there to help you out with the 6 liters. Now, I've been using this chart that you can see before you for the longest time when explaining the drivability of a 6 liter and the operation of a 6 liter engine. We look over to the right here, and you're going to see that oil starts off at the oil pan because we're talking about a Huey style injector. In other words, we need a hydraulic electronic unit injector where we're using hydraulic pressure to pressurize the fuel. So on one hand, Ford has been saying, under service information, that there is a minimum of PSI for ICP pressure. Again, we call it injection control pressure, your ICP pressure on the high side. But then we have our fuel pressure over here. Where's our fuel pressure? Right there. So therefore, you're going to see the fuel pressure is now 55 because this is old news, but pretty much every truck out there should have the blue spring update for the fuel pressure regulator. Funny thing is, yesterday, when I was diagnosing truck, I measured fuel pressure and she was at 45. So that tells me it hasn't had the update. So there's still quite a lot of 6.0s that haven't had the update for pressure from Ford itself. So they made the update. Yes, I know there are kits that can take you up to 65 PSI, if not more. But I'm not going to lie to you. The more the pressure that's applied, it seems to the engine work much better. So in this case, upping that pressure is a good thing. So definitely we're going to sell that customer that spring minimum to actually take it up to 55. But let's go to this guy over here on the side here, which is your low pressure and high pressure side of things. We start off at the oil pan. We said that oil earlier, and then we got our oil pump. So that's our traditional engine oil pump, which I'll show you a picture of it later on. And then we got that reservoir that's underneath that oil cooler there, along with the high pressure pump. So it's all one thing feeding another. So you cannot have, high pressure ICP unless you got that oil pan oil pressure, that engine oil pressure there. Well, as you know, there's many auto parts stores that are selling you that dome cap or that taller engine oil filter cap. And the problem is sometimes that bypass will just continue to bypass and it will not build engine oil pressure, and that'll cause a no start. So many times, one of the first things we do when we do see that the engine won't start and we see low ICP pressure on our scan tool, we go after that oil filter, and you see this big dome filter, and that usually is a red flag sometimes because that may be the issue. Because as you know, there's a retainer clip they put in it too inside of the pressure bypass. That could be the issue. So sometimes we take the cap off, we'll have somebody crank the engine over, and we'll see if we actually fill it up. So I guess you can say, yes, I'm anti dome cap. I got to use the factory cap with the traditional filter that's supposed to go in there. That'll make a whale of a difference. Though I know there's many trucks out there running with those dome caps, but it's a big no-no in reality because we've seen the understanding, and even Ford has made mention about what the disadvantages are of it. So, but having a good quality oil filter is very important. So, but let's go to the ICP. Now that ICP sensor over here, that ICP sensor, which sits on the valve cover on 04.5 and laters, and then it's located next to the IPR on the early 03s and early 03s and early 04s. Well, that ICP sensor can be a pain in the butt. Let's talk about first the 03. The 03s, you're going to find out that they're notorious for leaking, and is often, even to the day, misled technicians because they think they have a rear main seal. And if they actually look upward, they will see in the rear cover that it's probably coming from the driver's side there on the ICP sensor. And one thing we like to do is, and if you look at the drawers of my toolbox, one of them actually has an ICP sensor for these, because many times when I've had to disconnect it, it is so hot and brittle because there's so much heat. And yes, there are shields missing, and those shields are missing. It's very brittle. You'll break the connector. Now you need to install a new ICP sensor. So yeah. Now, the ICP sensor, though, as you will see in the following slides, can cause a fishbite effect. It still does it, where the truck will run great, and then it'll snap, or like you feel it surge, but it's very sudden, and it's so intermittent that ICP sensor is the best thing. So I'm sure most of you know that these trucks can run with the ICP sensor disconnected. So you can disconnect it and drive it and see the fishbite or the surging effect is still there. Easy peasy thing you can do. So obviously, if it's an 04 and later with the ICP on the valve cover on the passenger side, is a quick and easy thing you can do to disconnect. So Now, the IPR. The IPR is, we've had many trucks come in with no ICP pressure and the IPR is stuck. As you know, the IPR is nothing but a solenoid with a plunger. So it's spring loaded. So therefore that IPR is normally what? It's normally open. So if it's normally open, that means it's dumping the pressure, won't start, right? So therefore, when the key is on, you're cranking, the IPR is commanded closed by the PCM, it energizes it. So therefore it closes it. So therefore that plunger can actually get stuck. So therefore, you're going to have some situations where you don't have any codes for the IPR, or maybe an IPR performance code, but definitely an ICP low pressure code set. And you're going to try to diagnose it, and you're going to see you're going to have a leak, and you're going to command the IPR. And in this case, the IPR don't move. So please note that we've seen guys replace various different, from high pressure oil pumps, Jesus, high pressure oil pumps. And they've done this because they never looked at the IPR first. So anytime we have an ICP issue, our policy is we're going to go ahead and pull that IPR off. Yes, some of you gotten good at it. My big hands, they're very hard for me to get in there, but I get in there and we take that IPR off because you want to make sure that the IPR is not to cause your problem. Not to mention, you're also looking for any type of contamination there. So is anything falling apart there? So now, obviously, we see the electronic side of things, and you'll notice we have our ECM way up here. So therefore, there's our ECM. We have an ECM that's used on the VT365s, which is the international version of the 6-liter. And in this case, there's a PCM that Ford likes to call because it also has transmission controls. The main input sensors are many, but the real hardcore ones are your crankshaft and camshaft position sensors. So one thing you want to look at is, do you have a good PID of yes, right? Now, the trivia question I've always asked is that how do you know if you have a sync signal? First of all, excuse me, you have no sync signal. So you're sitting there doing a crank, no start, you got no sync signal. Do I have a PID that reads yes? Okay, so it's supposed to read yes for both FICM sync and for your standard sync signal. So here's the deal though. You're going to have maybe a no sync. So you're like, I got a crank or cam problem. So the question is, how do you know if it's crank or cam? Well, one of the things you can look at, if I have time, I'll try to show you in the service manual, but in the service manual clearly shows that there should be a fixed duty cycle for IPR if you lose the crank sensor. In other words, she won't go over 380 psi. So it'll stare at you under 380 psi. That's probably telling you with a company with a no sync signal that you probably have a crank signal. So the crank is lost. So it defaults to that. That is what it does when it actually sees no crank signal. Obviously, your sync PID will read no, but your IPR or ICP, excuse me, your ICP pressure will be no greater than 380 psi. So be aware of that. Now, the next thing is the IDM and FICM. Oh, we all know about FICMs, but please note our policy is anytime you replace the FICM, you should replace the FICM relay as well, because that means, and if you look at the scantles, you can see that where you see the battery voltage applied to the FICM because it measures it, and you can see also the relay power. So that is actually going to tell you if you do have indeed a high resistance fault in the actual relay itself. Yeah, I'm a big relay stickler because as I know, these trucks are aging and these relays are getting worn out. So now we all know about pulse width at 48 volts. Please do me a favor. You can read that on the scan. So when I see a guy back probing into the FICM to measure that 48 volts, I'm like, what are you doing that for? The computer does it for you. So believe it or not, you can say that it has a built-in voltmeter to measure that 48 volts is supposed to be applied. So hello. So there you go. Now, it is important to understand that when you look at if those are trucks that haven't been modified, to make sure that the DGR is not stuck open, because if it is, like this truck I worked on yesterday does have the working EGR, and let me tell you, that EGR was coked and baked, that intake. I can tell you how badly carboned up it was. So that's another issue we got to address too as well. In other words, we need to clean that intake manifold along with that EGR, perhaps replace the EGR. So be aware of that as you work on these. So now, last but not least, in your diagnostics, let's not forget about compression. I visited a lot of shops back in April and May, and I can't tell you how many shops I stopped by and we were talking about diagnosis, or we actually worked on a truck and they didn't have a compression gauge adapter for the 6-liter. I'm like, well, then how are you doing it? So, like I've said in previous webinars here not too long ago, please note it is normal to sell a customer a compression test, because if this truck comes in, like this one I just dealt with. Obviously, I don't have an engine running problem, but if it's got 300,000 miles plus or 200,000 miles plus, I don't know the overall condition of the engine because I don't know how it's been maintained. So, like I've said before, it's like me walking in a dark cave. I don't know what I'm going to see. So, I can't tell you many guys will diagnose smoking issues and never bother to look at compression. So, yeah. Now, I know a lot of you gung ho guys, they like to do the relative compression test. That's okay. But I need to know where the number's at because is my problem in the lower end or in the upper end? Meaning, is it in my valve train, my cylinder heads, or is it in the lower end where the pistons are at? Food for thought. So on the high pressure side here, you can see an O3. How do I know this is an O3 model? Because it has the cylindrical oil rails. You can see these cylindrical oil rails right there. So therefore, they're actually cylindrical. They're not the wavy. Let me skip a slide right there. You're going to see the wavy oil rails, which was used on O4 and laters. So when we look at the old school style O3, you're going to notice it's just a high pressure system that is plumbed. You guys should know your 6 liters. Obviously, I'm not doing a basic 6-liter class, but where has been the issue? Issues. Well, the high pressure pump covers have been an issue where it mates with the leak, and obviously the mating between the rail. Same thing. We can see that there's that high pressure pump that we accelerated. Why? Well, turns out that we actually had. Hold on a second. There we go. Turns out that we actually had the teeth were not lined up properly, so it was literally grinding away on the cam gear and on the gear for the pump. So it is essential that you sit that thing down, make sure that the gears are lined up with the camshaft gear. So be aware of that. And we also got our traditional places where we leak. But one thing I'm going to show you in the upcoming slide is the snubber valve. We've been talking about that snubber valve. Now, I know a lot of you guys know about the dummy plugs that sit over here. Yes, the dummy plugs. But in this case, the snubber valve needs to be inspected for any debris on these high pressure systems. So, two things I want to show you on this O3 is number one is, first of all, the snubber valve on this application is internal right there on the entrance. I don't know why it's doing that. Hold on a second. Let me erase this. Yeah. But anyways, what we're trying to show you here is that we're trying to show you that. Let me go ahead and erase all this. All right, let's try this again. Right here, we're going to see that there is a snubber valve there. Okay, so when you take that fitting off, you're going to find yourself, there's kind of I guess you can say a diaphragm with a spring that actually dampens the pulsations. Well, that's a haven for trash to accumulate when you have IPR failure. So in this case, that's a good place to look. The second thing is the plug. Now that plug right there is actually there for, actually that's where we fill it. So we still have a lot of technicians that are not so experienced with the 6-liter that anytime you remove that rail and you drained it, you put it back on, you're supposed to fill it with a hand pump. And if you guys have a fancy oil pump, that'll work too. But you're supposed to fill that rail up with oil. That's what that plug's for. Well, I had a truck that we were diagnosing once, and it was actually not building enough ICP pressure, build and it not build. And turns out that our leak was on that plug. Well, I'm like, oh God, where am I going to get an O-ring for that small that will hold, So I called Ford, and believe it or not, Ford stocks them. So I have a little baggie in that same drawer where I have my ICP sensor that actually houses extra of those plugs. So if you do a service, you do an injector, and if it's aged, you may want to take that plug off when you fill it up with oil. You may want to check to see if that plug has got that O-ring just tearing up because it's going to age eventually. So. And you're going to see that same plug on the wavy oil rail right there for those of you who've never seen it. So therefore, that's what you're going to see there. Okay. Now, this is where our plug is, but we're going to look at the snubber valve. But here's our dummy plug over here, and over here's our ICP sensor that many of you know. Now, when I initially do some testing, if I want to do a quick test without having to get the IPR, I know I said I like IPR, but if I want to do a quick check, I want to see if I got a leak, the customer's really cracking down on me. Yeah, we'll do a leak check through the ICP sensor hole. We'll take the ICP. We already have adapters that we copied off the thread, and we went ahead and we'll put nitrogen or shop air. But you got to make sure it's clean shop air and dry. Got to make sure you do that. So therefore, it's essential that you do that when you actually do a test. Now, the biggest challenge that I got, and this is where I go back to the that technician that's kind of a butcher because what we find is that I know that anytime I'm going to do injectors or I'm doing an ICP leak, I got a leak somewhere, that these Torx bolts, are never torqued down to specification, and I know that they're often broken along with the valve cover bolts, so I'm like, if it's got an oil leak at the back, I know that most likely they broke a valve cover bolt. So there's no reason why it is, and I know it takes time. You want to put that electric or air operated 4-inch drive ratchet and you want to take it off fast to make your job faster. Well, at least loosen them with the ratchet, not with the power ratchet. So therefore, you got to loosen because I can't tell you how many trucks, the bolts are broken heads or like the Torx head is stripped. It's just a pain in the butt. So please be gentle with it because I blame a lot of technicians for even bolts missing, from the oil rails it's held down. So that's a big thing too as well. So. But anyways, as we were talking about the ICP sensor, this is the ICP sensor right here that was located next to the IPR. Obviously, this is the IPR. Some of you guys should know that already. But that's the connector right here that I told you that can often be broken because of where it lives. So if you look above, there's a heat shield on this, but I can't tell you how many shops don't put back heat shields, and a lot of them, pretty much almost 90% of the 6 liters I get, they've already been worked on at a dealership or at a shop. And guess what? Those shields are missing. So therefore, and there you could see a better view of it from the Ford Service Info, the old book right there. And you're going to see that, there's all the shields there. So now we have had quite a few of them, a little bit come with shields on. Obviously, it's harder to get to the IPR from the backside unless you go from, removing the FICM. So but anyways, just be aware of the heat. And yes, there is a insulation cover that you should be putting on the IPRs. So if you got to zip tie it back on, that's fine. Just understand that, don't let it touch the heat because that zip tie is made out of plastic too. So now, many guys don't buy the tool to actually close the IPR. I got 2 of them. I forgot. I ordered one. I did forgot. Anyways, I got 2 of them where I can command the IPR. What's an OTC tool that you can plug into the IPR and you can close the IPR. So when you're leak checking, you got nitrogen or air going either through the IPR or the ICP sensor. You got to understand what your IPR is closed. So if we look at the computer, pin number 2, okay, pin number 2 right there is actually what? That is your IPR control. So if I look at the wiring diagram, you're going to look at the wiring diagram and you're going to notice that right over here, there's your IPR right there. Hopefully I won't get that funky line, but that's your IPR right there. You can all see that. Now you'll notice the IPR will get powered through the key on the top. So it's always applied battery power when the key's on, okay? But the grounding of that IPR is at pin 2 at the computer right there. So there you can see your PCM right here. So therefore we'll look right here. That says your PCM right there. Okay. So therefore one of the tricks I like to do is you're going to notice that the wire color going from the computer is yellow and red. It's a yellow wire with a red stripe. So therefore what you can do is you can actually get to the engine connector and take that cover off, and you're going to see it's obviously take the dust off or clean it off, and you're going to see there's one wire that sticks out like a sore thumb at pin 2 of the 46 pin connector that's yellow and red. So what I like to do is I will actually back probe on that yellow red wire at the computer because it's easy to get to. And if you want to remove that driver's side battery, that makes life easy. You can still run off the passenger side battery. And at that point, you can back probe pin 2 and ground it. That's all you're doing. You're not going to hurt anything. Because all it does is ground the IPR. So you can ground the IPR, and at that point, you ensure that the IPR is indeed closed. So that's an old trick we've been doing for years. So obviously, if I don't want to take the FICM out to get to access, because my big hands need access to get to that IPR, if I want to close it for a quick leak check going through the ICP sensor hole, once again, I'll take that engine cover off of the engine connector, and I'll look for that yellow red wire, back probe it, ground it, and there's the IPR closed. So there's a big quick trick you can do. So there you go. Okay, so we mentioned about the fish bite effect, about the ICP sensor. So once again, if the vehicle is assembled, usually have a glow plug bracket depending on the model, because you're going to find out there's many brackets. They usually like one stand. You got one bracket sits like this, one sits vertically, and one that goes over the top. 6 liters came in 3 different ways. So obviously you want to get to the ICP sensor and disconnect it. I don't need to tell you how many times you pull an ICP connector off and you see it's full of oil. Yes, that mandates that you have to replace the ICP sensor along with the pigtail connector going to the ICP sensor. So there you go. All right, so for 6-liter general specs, always remember that the firing order is 1273456 8. Well, that's the same one as a Duramax, if you know Duramax applications. It is still a 4 overhead valve displacement, but it's just a 365 cubic inch engine. So when we look at today's engines and we look what these 6-liters can do, I know the aftermarket has coming out with head modifications, whole different heads. You're doing the fire rings and so on, right? The problem is, you got to understand that this motor can only handle so much. So when I see these heavy horsepower modifications, the question begs, huh, how long will it live? So we have found out now through time that the best, longest living 6-liter is the one that's not modified. You know, I just talked to a guy on the phone. His truck has over 600,000 miles, and yeah, he's done the heads once. But the thing is, he runs a stock program. His injectors have gone a long time. He's done maintenance, so it kind of proves that 6-liter has the capability to be a little bit reliable, but it does work. And as you know, I own an '06 as well, and my truck has 100, but I got some issues happening now, which might be of my doing. But I'll talk about that here in a bit. Let's talk about fuel pressure. As you know, many customers don't realize there is a cap right there where the HFCM, horizontal fuel conditioning module, is located at. You'll see right there that there is your primary fuel cap. Will you please quit over torquing them? All right, I can't tell you how many people over torque them because they're squashing the seal, and you might find moisture right here of fuel. Might smell a little bit like fuel. That means that cap is not sealing well anymore because somebody put it extra tight. And like I've said before, we've had those caps super tight that we had to remove that whole assembly and literally drill it and break it apart to get it off the housing itself. Now, the HFCM, believe it or not, has not just the primary filter, but also the lip pump. I got to tell you, my lip pump on my vehicle is still the original. Those lip pumps go a long time. So when people want to modify them with an aftermarket pump, I don't know why. Because for a stock truck, this actually works great. The pump's been doing wonders. It works great. Unfortunately, you do know that the fuel pump relay is embedded in the whole fuse panel, which is underneath the steering wheel. So if you need a fuel pump relay, you're going to have to replace that whole, thing. Now there's guys that show out there that are showing you ways of cutting into the wire and you can put a relay yourself. That's a little bit of work, but you could do it. So therefore that could be modified to put that in there. But anyways, what do we look at here? We see the fuel pump power, we see the fuel heater, we see the returning power. But one thing you're going to realize is that one thing I have in my toolbox that I use once in a while is not so much as much as I used to, but there's a hose that they sell from Ford that actually puts an inline clear hose there because they want to know if you got air going back towards the tank. And the air may not be coming from the injectors. Everybody knows the bubble test that you can do, or the balloon test. And in this case, no, that could be air coming from where? Well, that could be coming from the cap itself. So therefore, when I say from the cap itself, it's actually coming from the cap leaking. So therefore, you can be getting air through there. And that could cause premature injector issues too as well, and some surging if the air is substantial. So very rare it happens, but it's been known to happen there. So be aware of that. Now, as I was diagnosing this truck yesterday, the complaint was intermittent stalling problem. This is a never-ending problem with 6-liters, especially with the old 6-liters. And what it is, I'll give you the cause right now. The cause is the inertia switch. And I even made a YouTube video on my channel about this where I'm telling you how you can use a fuse to connect and to just bypass. So you'll notice that, on the control side of the relay right over here, you're not, excuse me, not the control side, the switch side of the relay, you're going to see the switch contacts right there. So what you're going to find is that that can be bypassed for testing purpose. So if the truck, I go test drive it, it stalls, one of the things I can do is I can go ahead and just what? I can just bypass it. So therefore, it is not a sin for you to put a bypass between these two wires, the ones coming into the inertia switch. So the inertia switch is located there on the passenger side on the bottom of the kick panel. Take the kick panel off, and you're going to see this thing with a red button on the top. That's where you set it, and that is your inertia switch. Okay, that inertia switch for safety reasons. So in this case, it can be bypassed, but this is like my fourth, fifth truck that I've had intermittent stalling caused by the inertia switch. Now, usually if this were a 6.4, I'd be going after the relay too. But, because 6.4s are notorious for that. But on the 6-liter, I can't do that because, like I told you already, that fuel pump relay that you see right here is all what? Is all embedded. It's all part of the central junction block. In other words, that fuse box underneath that steering wheel cover. So, unfortunately, that's the case. But now, when we're diagnosing this fuel pump circuit, you ask yourself, because I did have on this truck that had the inertia switch problem, a code set saying that low voltage going to the computer. So you ask yourself, well, how was there low voltage going to the computer right here? Well, you're going to notice it's not labeled on the PowerStroke 6 liters, but is labeled on the 6.4s and 6.7s. So therefore, as I move around here, you're going to see this guy right here, pin 19 right there, going to the PCM. That pin 19 is better known as your FPM. So if you backtrack that pin 19, I'm trying to get this here. If I backtrack, you're going to notice it's tapped into the wire that goes to H, and H continues on over here, which goes on to the lift pump right there. Okay, it's a continuation of the wiring diagram. So in this case, let's go back to that pin 19. That is called the FPM, also known as your fuel pump monitor. So as I look at pin 19 over here of my connector and view ID, you're going to see that that pin 19 is your fuel pump monitor. So another thing I can do is I can test drive the truck, and I put it in a graphing form so it shows it on. And if it drops out and the vehicle stalls, I know that I lost voltage and not fuel pump monitor, because that's what he's doing. If you look at the diagram here, he's literally monitoring the voltage. Is there a voltage signal? In other words, is there power going there? So he taps into that on pin 19. He's connected in parallel with it to monitor that fuel pump to see if it's getting power to it. So if I do have power, that means up to pin 19, that wiring is okay. And the fuel pump monitor on the scan tool, that's a PID you're going to read. It's going to read on or off. So therefore, that's telling you it's there. So if you ever ask yourself, how did the computer know there was low voltage? Because the code clearly showed that. I want to say it's a PO, P1, 139, 138. And in this case, it said that you got low voltage going to the fuel pump. Well, it could be the fuel pump monitor. So that's what FPM stands for when you look at pin 19. So there you go. All right. All right. Moving on. So other tips. We've talked about the high pressure issues, obviously the labor involved, but like I said already, you got to inspect. I've been using this little sheet just to show that you got to inspect the IPR. You know, these guys at this, the shop, they send it to me and they show the one installed, the one they took out of the truck. It's a never ending story that a lot of guys don't check the IPRs. Got to check them because there's a screen missing, and that screen could be small or big. There's two different styles. And you're going to see that, if there's metal in it, this is a nice one, by the way. Usually they're just destroyed, or that whole ring itself is actually gone. That's why we like to take a pick and go into the bore where that IPR goes in, just to make sure there is no screens and there are pieces left in there. So sometimes I'll use a borescope to get in there just to see if that screen is still in there. So there you go. Now, when it comes to oil pressure issues with the 6 liter, obviously, there's an easy place. So if I look straight down towards the oil filter right there, there's your oil filter right here. But right there, that guy that I circled right there, that is your engine oil temperature sensor. Now, the engine oil temperature says you got a straight shot to it, so you can stick a socket in there and take it out, and you can make your own adapter to measure engine oil pressure. So this guy's engine oil temp, this is engine oil pressure, but this is a single wire application, meaning that it just has one wire. It grounds. So therefore, you probably know that this oil pressure gauge on your dash is just on or off, on or off. That's it. It doesn't measure true pressure. That's why for ease of access, we use the engine oil temperature sensor to measure that. So there you go. Now everybody knows about the oil cooler and engine coolant variation in temp, that delta temp. That has been a never-ending story of discussion, even on forums that I come across. Yeah, under heavy loads, if you're pulling a trailer, it is normal to see that delta actually separate, meaning you might have 205 degrees of engine coolant temp, and it might climb to 220. But after you get down under that load, it should stabilize itself. So those temps should be closer to each other, at least within 5 degrees with each other. I know people use the 10-degree window, so I am aware of that. But the way that engine oil comes up is through this hole. Now I'm going to show you another diagram here. Let's not forget about this hole right here going to oil cooler that feeds the oil cooler. Because if the customer has been very bad about engine oil changes, that bore right there that I'm circling over and over right here is actually can get clogged with hardened carboned up oil. So we literally can have a high oil pressure issue. We'll talk more about that here in a bit. But again, that is that hole that supplies engine oil pressure there. But let me sidebar here. You're going to find that this is your reservoir. So unfortunately, every time you change oil in the 6-0, for those who never realized it, there's always about a quart of oil sitting in this reservoir. So everybody knows about this screen, I'm sure. So in this case, this screen can be blown through. That's what feeds oil from there to the bottom. There's a passage here that goes to the high pressure oil pump. So as we look closer here, you're going to see the cover removed, and obviously you're going to see oil go to the bottom fed. So this is a bottom fed engine oil pump. So this is high pressure oil pump. So therefore engine oil pressure goes in there. But what nobody realizes, let me backtrack over here. You're going to find out that this passage in here, that whole area right there where that reservoir's at, that's pressurized oil in there. That's why when we do oil coolers, we tend to put around this whole cover area right there, okay, we tend to put, additional sealant. You might criticize me, but trust me, I can't tell you how many oil coolers we've done in the past where we had oil seeping out of that oil cooler mating to the block mating. So one thing we like to do is on the rubber seal itself that's on that oil cooler, we actually put some additional, which we like to use the right stuff. We'll put a bead in there just to ensure that we don't have no leaks, because that has been a problem in the past. Yes, we torque it down. Don't criticize me. I'm just telling you, they seep oil. So therefore, that can happen from time to time. So be aware of that. But anyways, talking about the low pressure oil going to feeding the high pressure pump here, please note that O-ring right there is going to be an issue. So let me go ahead and erase it. We're starting to see more and more of those happening as these things are aging. These vehicles are aging. So therefore, let me just show you here. I'm going to blow it up. And in this case, you're going to see that nipple right there. Hopefully you can see my cursor, but you're going to see that nipple right there. You're going to see that O-ring fail. It'll be cut, and that is where you found your leak, right? You might have been going crazy trying to find the leak. You take the high pressure pump cover and bang, that seal is cut. Now we've seen this guy leak, and also the one at the base of this high pressure line right here going to the STC fitting. So therefore, this can leak and this leak. So in the event this nipple leaks, you got to replace. Let me rephrase. Hold on. Let me stop. Stop. One more time. If this O-ring is torn, you replace not only this line, but you also replace the high pressure pump cover, the cover over it, because the cover board, that means that she's worn. Now, if the base seal between the pump and this line is leaked or torn, you replace the pump and the line itself. So be aware of that, because we've seen many guys do all the labor, put an O-ring, put it all back together. It fires up within seconds. You lose ICP pressure, it stalls again, rip the seal again. That's how fast it can happen. So again, be aware of that. So food for thought. Now, obviously, the pump can fail. I'm not going to lie to you, it can fail. So therefore, that can happen there. So too. So the nightmare ones that still happen from time to time, not as a high fit as we used to, is we used to see this branch tube actually leak, the one that feeds to both, which is this guy right here, right? Here you can see a $120 part, which is about mostly probably in excess of 10, 15 hours of labor, because the trick is to get to these bolts right here. So some of you have mastered it, some of you have not. And in this case, it does require the head to be removed. But the problem is to get that line off, that rear cover's got to come off. So that means the transmission's got to come out, or the engine's got to come out, or cab off, whatever you want to choose. But yeah, it has to come off. So it's a high labor item if you should find pieces. I have seen these welds actually leak right here. I don't know why it keeps doing that. But in this case, these have leaked too as well. So sucks. I know, but that's what happens. So all right. So hopefully that's helping you out for those of you that are novice at this. So therefore, please know, yeah, that little bolt right there can be a pain in the butt. So therefore, be aware of that. Okay. All righty. Now, the 05 and laters do have the cast iron pump. And I got to tell you, if I've done 3 or 4 pumps in the last, I don't know, 10, 12 years, it's been a miracle. So these pumps are pretty damn reliable. But in this case, the quality of engine oil is what can destroy it. And you could get a defective one too as well. So this has been a good pump in my opinion, because again, I haven't seen too many issues with them. Now, since we're still talking about the high pressure side, I talked about the snubber valve. Remember I said the snubber valve? So in this case, when we look at the snubber valve, you're going to see right here that that snubber valve sits right there that nobody ever looks at. So yeah, inside of that tube, you're going to see on that fitting, you're going to see a diaphragm, a metal diaphragm and a spring. That's where a lot of trash collects, and that dampens the pulsations. So what am I getting at here? You're going to have a truck that might have premature failure of the injectors. Now, the injectors can actually be failing prematurely. Maybe they'll go 10,000 miles. A lot has to do with that snubber valve. The quick check you can do is look at IPR duty cycle on your scan tool PIDS. That IPR duty cycle should be somewhere around the 30 to 32 percentile. But if it's engine's idle, it should be fixed there. It shouldn't be moving that much, that percentage. Okay, looking at your PID data on your scan tool. Now, what can happen though is that if that snubber valve is broken off, you're going to see the IPR struggling to maintain pressure. So therefore, at one given moment, it'll read maybe, oh, I don't know, 20%. And then it'll go to 60%, 40%, 30%. In other words, it's not holding steady. That's classic of one of two things. Either the snubber valve is bad, or your IPR is heavily, that plunger is heavily failing, which I haven't seen very much. It's mostly been the snubber valve. So quick check that you can do, because that would mean that on the injector intensifier piston, you're going to see a lot of fluctuation. So now this is not a full-blown 6.0 class. This is a tip, so I'm not going to go through everything of the injector, but as you know, the injector is using an intensifier piston. So let me blow this. Well, I could work with this. You're going to see that you see the intensifier piston right here, right? That intensifier piston is pushed down by the high pressure oil coming in, right? So that high pressure oil is controlled by this spool valve. That spool valve is controlled by the two cylinders which work with 48 volts. High pressure oil comes in, it pushes down on the intensifier pistons, which down here, it pressurizes the fuel right there, okay? Now, high pressure oil pushing down on fuel pressure, it's going to pressurize the fuel and take it to somewhere around 3,100 psi. So it's a 7-to-1 intensifier piston. That's a whole different chat. But what I'm trying to get across is if that high pressure oil is fluctuating so much due to a snubber valve just stuck or pretty much just not moving at all, not dampening the pressures, that means that as intensifier piston is going down to pressurize the fuel, is not going in a linear form. It's doing what? It's actually fluctuating so much. And it's just beating the holy heck out of this spring, which can break the spring. So just be aware of that there. So. Now, that pressurized fuel, as you may or may not know, will actually cause a pressure differential effect. So that pressure will actually push up on the nozzle and cause it to open, and then those passages are going to squirt fuel down here. So as you may or may not know, the side of that injector, when you look at it from the side, you're going to notice right here, that is your fuel passages right there. So obviously we got to make sure we torque, and guys, we still get it wrong. I can't tell you, mostly do-it-yourselfers, I would like to think, that are screwing this up. You need to torque that injector down to specification. So, and note, when we talk about stiction, I know stiction occurs, and in this case, it's only 1,000, less than 17 thousandths of an inch that we're moving here, that spool well goes click, click, click. So when you do your key on, engine off, injector self-test with the scan tool, always listen, click, click, click. It'll click one at a time following the firing order. You need to do the audible. In other words, you need to listen to that clicking, because electrically, that's all it's testing. So you can still have a sticky spool valve. So the way we nail them sometimes is not only through the power balance graph, but also through the self-test with the injector self-test. I'll do it many times. So what you're going to hear is it'll do all of them together. You'll hear this click, click, click all the way. And then you're going to hear click, click, click one at a time when you do that. And that I'm counting, I'm literally counting 1 click, 2 click, 3 click, 4 click, 5 click, 6 click, 7 click, 8 click. And that's telling me that those spool valves are moving. So if I have a sticky spool valve, I'm going to hear nothing. So therefore, that's why you want to make sure you can audibly hear the clicking of those. I hate to say buzz test, but it's not a buzz test, it's a click test when you do that injector self-test. So now, obviously, with the scan tool, even my Snap-on scan and other scan tools now give you a power balance graph. Now, I'll be honest with you, the IDS is the prettiest one because I can see what's clearly going on in terms of power contribution to make sure all the cylinders are working. Not only can we do it on a cold start, but we can do it also on normal operational drivability. Now, the trick some of you may not have done is I can do a slow acceleration, because I've had 6 liters with injectors that will actually misfire under light throttle. So I will look at the graph and all the cylinders will be working, but I'll give it a gentle amount of APP application. In other words, I'll hit that pedal slowly with my foot, and I'm watching my screen on my scan tool, and I sometimes can catch all of a sudden, bang, a drop in RPM like you could see here. And in this case, that's telling me, oh, I'm dropping a cylinder. So that's the injector that's actually the issue. Obviously, don't forget about compression, like I said already. So, relative can be done, but then finally, if you want to make sure, you better go ahead and do a compression test, because I can't tell you how many technicians out there have replaced an injector. That didn't fix the problems, and turns out it was low compression. So there you go. Now, as you know, the fuel passage, as we showed you on the injector earlier, there's your fuel passage right there. That fuel passage is very essential, but if that injector is not seating properly, that, in other words, you under torque or over torque, both situation will cause this, that can cause a lot of compression blow by, in other words, combustion blow by, and that will pressurize the fuel. So if you look very closely here, if you have gas is going in the injector, because the injector sits in a sleeve, you're going to pressurize the fuel, and that's where you will get aeration of the fuel system. That's where many of you might have done the bubble test or balloon test, where you take the secondary fuel cap cover off, you'll crank the engine with the key off. You don't want the lift pump working, so you'll manually crank it with your cable there, whatever you do to get that started to crank, and all of a sudden you'll see bubbles there. That's the bubble test. What's the cause? Most likely, as you can see here, the combustion gas has just toasted this tip of injector, and it still happens. We've been talking this for years, and it still happens. So now, when it comes to nipples on that in top of that injector, I'll be honest with you, I've only done maybe two. A lot of people don't realize those two ports that sit on top of that injector are your oil exhaust ports. Okay, let's get that clear. Those are oil exhaust ports. So therefore, when that intensifier piston goes back up from spring pressure, pushing it back up because the spool valve closed, right, goes up, you know, that means that oil has to be exhausted out. So when guys do a leak test and they have the valve cover off and they see bubbles coming out between the injector and the nipple, they think it's nipple or injector seal. It's actually normal. Okay, so depending on how much oil, residual oil is sitting there, some will gargle pretty good, but some of them will be quieter than others. There's no consistency if you've done enough 6 liters. So therefore, what I'm trying to say is just note that it is normal to hear hissing or some bubbles, air leaking, not because of the nipple, but not because of the injector, but it's just normal coming out of those two ports. So food for thought. All right. Now, as you know, the valve carrier is all held down. That whole valve carrier assembly, is all held down. You do want to inspect those rocker arms, because we have seen these rocker arms crack. Usually when I see, for example, if I drive my 06, when I used to have my toy hauler, I used to have a 34-foot toy hauler. And I had this toy hauler loaded because I used to have a drag Jeep a long time ago. I used to drag Jeeps with a big block Chevy. It was fun. But anyways, I'd be going out to Dumont, so I take the I-15 south. But when you get over the Scirocco summit, there's like about a good, I want to say 15 miles that you're just getting some high speed. And you got to watch your braking and so on, because, you're going pretty high speed. With my tow hauler pulling on my F350 with my 6-liter, this thing's going. So I used to have the truck in tow haul mode, okay? Now, what happened is that I tap on the brakes to slow down because I'm picking up too much speed. I'm going like 70, 75. Whoa, I'm going too fast. Got to slow down. So I'll tap on the brake to start slowing down. Obviously, I have trailer brakes. Don't get smart. So in this case, I'm slowing down. All of a sudden, when tow haul, it'll downshift. But the thing is, this thing went to 4 or 5 grand. I mean, the engine's roaring. So I see a flaw in the program that I'm like, holy crap, this thing is going way too much RPM. I'm almost redlining, but on a decel event. So therefore, when I have seen people actually take out a push rod on these engines, it still happens from time to time. It's always been, to me, high RPM, and many a times it occurs on a decel event when you're pulling the trailer, especially, or you got a lot of weight on the truck. You're just going to decel. So what did I do when that happened? I immediately hit the tow haul button and released it, and it immediately upshifted. So the RPM came back down. So be aware to talk to your customers about that, those that tow heavy trailers, that you better watch how you use that tow haul button, because that RPM went sky high. I'm going 75 miles an hour, and this thing went to almost 5 grand RPM. So yeah, that's where you can chuck a push rod out, and that's what happens sometimes. So I blame a lot of those push rods that tend to come out due to high RPM. And people say, well, I never redlined it. Probably on a decel event is my guess. So therefore, be aware of that. All right, so to talk about we see a lot of, I know I showed you this picture before, but I want to take a good look here. First of all, when you look at a cylinder head on a 6-liter, you're going to see this 6-liter doesn't have a whole hell of a lot of meat. You might weigh pretty good, but it's not a whole heck of a lot of meat on it. What I mean by that on this cast iron head is, look at how hollow it is. Look at all the passages. So you're going to notice here that there is this coolant passage right here. So I'm going to experiment with my truck. What is wrong with my truck? Well, what I told you what's wrong with my truck, like many other trucks, is that I could drive it all day long. I could take it anywhere I want. But once I put it under a heavy load, especially with a trailer, it'll just pressurize that cooling system big time. And it blows out the coolant and the engine starts to overheat. And I'm overheating because I'm blowing the coolant out. It's just pressure to the core. You all know about the pressure. You should know that that cap pops off at 16 psi, right? Okay, that degas bottle. So the thing is, the problem is the engine is not chewing coolant. What I mean by chewing coolant is not actually burning it or taking it where it's smoking. So it's not smoking at all. No white smoke, no nothing. And there's no evidence of coolant actually going into the combustion chamber. So in this case, the EGR is not there. The EGR's cooler is not there. So therefore it's been deleted. I didn't tell you that. But anyway, it's not there. So it's not the EGR cooler. So once again, the engine runs great. I could, like yesterday, I drove it. I never went over 190 degrees. So therefore I'm looking at that. That's running great. But I do know that the minute I put a trailer and I go up a hill, boom, it just pressurized. So I'm pressurizing. So keep something in mind that bugs me. So I'm going to experiment with this truck because I can't tell you in the past how many head jobs that we did, cylinder head jobs, where we removed the cylinder head and we're looking at the block with the gasket still in place, and we can't see where actually we got the compression into the cooling system. So therefore, we couldn't see it on the gasket. I'm like, I can't see it. Anybody see it? And even Mitch, my best tech that I've ever had, he's looking at it. He's like, we can't see it. Now, one thing we had a policy of doing that every time we did heads was to always do the sleeves. So many people don't do that, but we like to do it. In other words, we do the injector sleeves and we also do the glow plug sleeves. Okay, those are sleeves that are just inserted. So what my thing is that we suspect, and that's why we've asked machine shops to pressure test the heads, but especially on the injector and on the coolant side, because what's happening is that gases are getting, it only occurs when it's actually under load. So boost is high, that means the combustion pressures are high. So we suspect that we're probably leaking around the sleeve of the injector or the glow plug sleeve, and that will pressurize the cooling system big time. So I'm going to experiment on this one. I'll let you know what happens later. But in this case, I'm going to replace the sleeves of both on the injector sleeve side and the glow plug. Now, unfortunately, I've tried to think of a way to test this. I could try to pressure test through the glow plug hole, but I would need to have both valves closed to see if I build any pressure. So I could try that, but we could try that. But anyways, we're thinking of ways. If you think of another way, let me know. But in this case, I'm going to put a sleeves in. I'm just going to play around, reseal the injectors, put new sleeves on, and see what happens. So because compression test has been fine, and we've actually pressure tested the system, and guess what? It don't leak overnight. So I've done that too as well. We'll put a vacuum in, it holds vacuum, so it only occurs under heavy loads. So we're at high boost level. So we're guessing it's sleeves there too. Now, for those of you not aware, if you have done sleeves, one of the things we ask you to do is to always check. Let me erase this for a second. Is to always check the once you remove the sleeve, you need to see the surface area right there. Look at that right there. Okay. There's not a whole hell of a lot of meat there. And if you ever taken a sleeve out, you probably know what I'm talking about. That can be eroded away. So if it's eroded away, you're going to put a new sleeve on. You're going to get, in some cases, diesel in the fuel. Excuse me, diesel in the coolant. So diesel that is at 45 to 55, supposed to be at 55, will actually go into the cooling system right there. Okay, that's where we get that. So in this case, that could be the problem. So if it is eroded away, you would think you need to replace the head. But you guys, I'm sure, know that Accurate Diesel has been selling this sleeve right here, but it kind of shows you a better view without the glow plug sleeve inserted, how there is a little bit of metal there, right there on the cylinder head there. So there's your sleeve there you're supposed to use originally, but you put a taller sleeve there. But to accommodate the fuel pressure passage right there, you have to also modify the tip of the injector. So Accurate Diesel does a good job of selling us these sleeves that you can actually insert. Some of you have used it, some of you haven't, but in this case, you can see where you actually have seen that. So we're seeing more and more of these. So in this case, that's something you may want to take interest in if you have that kind of situation to put at the extended sleeve there. So yeah, be aware of that. All right. So another thing, we're going to go a little bit longer here, but what you're going to find out on the intake system, okay? The intake system, one key thing for those of you guys that are still running the original EGR cooler, always remember, what is the heat transfer that you are seeing in the EGR cooler? So in this case, you can have a lot of heat transfer, but note this is what we call a cold EGR because we're cooling the gases to that EGR after, so we're going to let it get a lot of carbon accumulation with it. So note that. And I hope you all are vacuum filling the cooling systems now too. So make sure there's no air in the system there. All right, the VGTs. As you know, I've been discussing about VGTs in my past presentations, but do me a favor, always make sure I stock, because that same butt connector you see going to the turbo is the same one to the IPR. So in this case, I like to keep one in stock. I literally keep that pigtail in stock because 9 out of 10 times they're hurt or broken on the IPR or even on the turbocharger. So make sure you have a good connection. If not, replace the pigtail going to that turbo. Now, the turbo itself, there's been so much on the aftermarket now, it's available with these turbos. Just note that that turbo is electro-hydraulically controlled. So note that solenoid on the side of it is controlling a spool valve that's controlling the oil to either drain or apply when you're actually moving that variable vanes on that turbo back and forth. So unfortunately, the sad fact has been that there's no vane position sensor. So one thing they've talked about with other 6-liter classes is to make sure that you actually test for turbo yes or no, and understand that that affects your back pressure dramatically, which unfortunately I can't get into this class. But one thing you ought to do is I do a load test on the turbos. Given that the scan tool allows me to do this with IDS, what I like to do is I'll raise the RPM to 2500, and I could also close the vanes. Now, since I was using yesterday my snap-on Zeus, I can't do that. So in this case, I would have to control the vanes and control the RPM with my foot and close the vanes, and you should see the engine look down. If it doesn't look down, in other words, feel like it's working, that means one of your vanes is probably in trouble. So you probably need a turbo, believe it or not. So be aware of that. Obviously, look for the exhaust leaks too as well. Now, an old school item that I had a guy call me a few weeks ago that he didn't realize about a 6-liter is, can turbo boost be affected by EGR? And the answer is yes. If that EGR is intermittently sticking, you will get turbo issues because that boost is being lost due to the EGR stuck open. So therefore, a intermittent sticky EGR will cause turbo boost performance codes to be set as well. And don't forget too as well that you actually have an intake manifold, and if that EGR is operational, what are you going to build up in there? Like I told you, like this truck I had yesterday, mega carbon accumulation there. Now, some of you might be using aftermarket cleaners. I use one made by BG where it actually squirts in there and cleans that intake, but sometimes that intake is so permeated with some hard carbon in there that you literally got to remove it and clean it out. So, or replace it. I have a spare intake lying around. So therefore I just swap them, and then that gives me time to clean that one for weeks on end, so. And lastly, we have the oil pump. Okay. That is your engine oil pump right there. Okay. Now I'll never understand how they could put a gerotor pump, as you see in the picture, around aluminum housing, which is the front cover. All it takes is a little bit of variation, and that takes out the pump itself. It'll start grenading. Always remember though, if you have engine oil pressure issues, that still happens to the day, you got to remember that regulator is right there. Okay, that's the regulator. So one of the things I like to do before I start taking it apart, let's say I got no engine oil pressure, right? I got very low. The question is it the pump, is it the regulator, or is it somewhere in the pickup? So the first thing I like to do is get to that little plug. I'll take that plug off and I'll check to see, there comes the piston, there comes the spring. If it's heavily scarred or there's traces of metal or babbitt, as we call it, that means that, yeah, something broke catastrophic. We got to go ahead and take that oil pump cover off. But if it's fine, it's just a little bit scarred, no big deal, put it all back together. Then at that point, we're going to do a quick test. What is that quick test we like to do? It still works to the day. I've been teaching this for years. We literally raise the rear of the vehicle. And by raising the rear of the vehicle, let me go over here. We raise the rear of the vehicle so that oil is sitting in the sump. Here you can see my sump right there. And what we're going to do is, by lifting the rear of the vehicle substantially, I'm actually pushing that oil in the pan to cover this area up against the front cover and the bed plate right there. So if there is a leak there, that O-ring has failed. It is leaking its area and losing its prime. It'll cover it up. Now I'll crank. I'm literally, like this on an angle. That truck is sitting like this. I'll crank it. And if it now builds engine oil pressure, then you definitely know it's in the bed plate, which is the upper part right here. Because this is the upper oil pan. Then you got your bed plate. You got a leak there. So there's 2 O-ring seals. Let me erase that. I went too buckle crazy on this. But in this case, what you're going to find is this is part of your upper oil pan, which is your oil pan gasket right there. And then you're going to see this piece right here. That is your bed plate. Then this goes to the front cover right there. So there's two O-rings right there, one there at the bottom, one there. Those can actually go bad. They flatten with time, and that's where you're losing your oil prime. But a quick thing you can do is jack the vehicle from the rear and let that oil go to the forward, see if it now builds oil pressure, and that'll tell you there's a culprit. But obviously, let me backtrack too here. You're going to find that, you're going to find that this gerotor pump might be heavily scarred or broken. Now, you're going to see that big myth out there where they're going to see that the actual gerotor pump has literally expanded. I actually have one sitting in the shop that I use for show and tell my classes, and it actually has expanded. That means to push that much hydraulic pressure to expand that and break it in half, literally that pump, yet it doesn't damage the housing. It's amazing. That means that thing saw a lot of air. So therefore, it's a lot of air. That's why, we need to make sure it's got 50 quarts of oil the way it's supposed to have, right? So quick tip right there. So now, we also showed you earlier the oil cooler, and I told you about that passage that can get clogged full of carbon. That's the passage right there. I recently had a phone call because, I take phone calls. I recently had a phone call where this guy said that he had massive oil pressure, that it was cracking the top of the oil cooler. The cause is not the regulator. I know what you're thinking is not the regulator. The cause is this passage is so heavily carboned up. That passage right there, hopefully you can see it. I don't know why I keep striping it, but in this case, let me do it one more time without striping it. Keep it steady, Tony, keep your hand steady right there. There, that passage right there. That one is, again, getting carbon suited up. So therefore, not suited, what am I saying? Carbon, in other words, hard oiled, it's carboned up in there. So in this case, that creates a Venturi effect. So as engine oil pressure volume goes in there, it sees a narrow opening because of the excessive carbon, it just raises the oil pressure. So in this case, that oil pressure is so high, it'll literally crack the top of that oil cooler. So that's a very rare thing, but as these trucks are aging, you're going to see this from time to time. So now I mentioned about removing the regulator right there. And I know I talked about that, but remember, if there's pieces of metal, usually it's, like I said, the needle bearings on a roller lifter. You got to understand that if it made it to the regulator, that means it sucked it up from the bottom there and it brought it all up. That means it's all over the whole system. So I'm leery about rebuilding those engines because I don't know if those needles bearings embedded themselves in the journals and passages in the block and in the crank. So that's the scary part, So you got to make sure you inspect that block because obviously you got to rebuild it at this point. So be aware of that. All right. All right, one last thing. I thought that was the last thing. First of all, remember, when you program a computer, there is a tag number. So therefore, that tag number is dictating what program you have or what program it takes to that vehicle. Because if you know the 04, 05, excuse me, 03, 04 trucks to the 05 and a half and later, the 05s and later spoke full CAN communication, while the earlier ones spoke SEP and CAN. So therefore, be aware that the computers are not the same. That's why for guys that put like an 06 motor in an 03, we see that happen all the time. That means you got to move over the engine harness along with the computer itself has to be shifted because it won't work, and vice versa too as well. So be aware of that. So obviously, these computers have been pretty reliable. From time to time, they do fail, but to say they're a high failure item, no. But the quick thing you got to understand is you better make sure you got the latest update and be leery of those trucks that come in with delete programs in them. So therefore, may have to make sure it's not delete because if the computer needs to be replaced and the customer bought this truck used has no programmer, and you put the a OE program in it, obviously it's going to turn on check engine lights, and that's going to cause problems there. So be aware of that. One of many things that we can discuss even further. I could go on and on with more 6-liter stuff, but time is limited. But hopefully we gave you some tips. We helped you out. Obviously, if you got more issues, let me know. My email is tsalas@dieseltg, which is traininggroup.com. You can email me. But in this case, we still got a lot to learn. A lot of guys that have been working 6-liters have been good R&R guys, but to understand all the details when it comes to wiring and all that, there's more to learn. So that's it, Mr. David.
Thank you very much, Tony. That was when you say hopefully you gave you a few tidbits. I think that you gave a lot more than just a few tidbits. That was excellent. Really appreciate that. But before we go too much further, I just wanted to mention the fact that this presentation has been recorded, and within a couple of days it will be up on our YouTube channel. So if you go onto YouTube and you place in there Lucas Diesel, you'll be able to find our YouTube channel. and be able to watch this program again, or any parts of it that you feel you have missed, and or that you want to share with anybody else in the shop. It's always good to have that, or as a refresher, maybe in 6 months or something like that. So keep that in mind. And as Tony said, here's some contact information. We really would like some feedback, like I said earlier on in the program, like some feedback with regards to these presentations. Are they good for you? What would you like in the future? Not that we can promise anything specifically, but we'd like to know, what is it that you're liking. So we have a couple of questions here. And in the chat, somebody put it, thanks, Tony, good stuff. So that's great. And there's several other compliments here. One of them there in the Q&A says, so many good points. Thank you so much. You mentioned, Tony, that you take calls. Can you elaborate on that?
Oh yeah, I actually do help people from time to time. So those of you that attended my training, they have access to me pretty much all the time. So either by email or by phone call. So
Okay.
yeah, I do tech calls. So therefore, I could be working in the shop and I could have one phone in one ear and my other hand on a wrench.
Yeah. Okay.
And the
Very
reason
good.
why I like do that, let me tell you, the reason why I do that is because I need to know what you're saying because I'm in a regional area and there could be problems elsewhere that could be occurring. So therefore, I try to keep open channel. And I tell people the best way to get hold of me is to text me. So therefore, definitely want to text me. That's the best way. And the phone number is on my webpage. It's the 235 number. So therefore, you can contact me through there. There's my phone number there. But what I'm trying to say is, the best way to get hold of me is to text me because I might be busy. And I won't get mad if you text me more than once. So, but I will say something, David, if you don't mind me saying, is that I've been cutting people off. And let me tell you why I've been cutting them off because you're not doing your homework. I am not making money off of you, and that's okay, but I'm here to help. But understand that if your questions are really in the dumb and dumber sort, where you haven't even looked up a code or haven't hooked up a scan tool, yeah, I'm going to be a little agitated with you because there's those that will come and call and they're amazing. They've done everything I would like them to do and they're doing their stuff. Now we got to brainstorm and figure out what's going on. So if you're not that way and you're just looking for answers, no, I'm not that way like other tech lines. I will cut you off. Sorry, but it's true. Do your homework.
Okay, appreciate that. Just as a pointer, you were talking about delete programs, or vehicles that have had deletes on them. I don't know if anybody read out there, but there was one shop here in the US who got prosecuted for deleting programs, and I believe they got fined somewhere in the order of $650,000. Don't keep me to those exact numbers, but it was a tremendous amount of money for doing a delete on a vehicle. So just beware of those out there. You were talking earlier on, Tony, there's a question here about changing the spring to increase the fuel pressure. You said it was a blue spring.
Yeah,
Um,
Ford offers it. So Ford offers it's the upgrade fuel regulator spring kit. That is a Ford
okay.
thing. You can buy it from your nearest Ford dealer. So
All right. Is there any way of knowing, say, for example, if you get a truck in the shop, is there any way of knowing whether it's had that done or not? Or,
simply by just measuring the fuel pressure. So in this case, you
okay,
should if you have 55, you have the update.
okay.
So it'll be right at 55.
How long does that take to do to change the spring?
Probably no more than an hour. Because
An
you got
hour.
to take the
So
two projects to get access. So it's no more than an hour upgrade. So
that would be a good selling point for anybody who gets a vehicle in the shop and says, hey, if you want your vehicle to run a little bit better, like you were commenting, you can change the spring and, for 1 hour's labor and the cost of the spring, that's a pretty good old investment there.
yep.
So, okay. Um, Somebody else put in here, we like to see 6.0s in our shop. There's so many good opportunities. And yeah, sure, there's good opportunities for making money, out of these vehicles because as the vehicle ages, there's more and more to be done to it. You were talking
Yeah,
about the
this
oil.
truck, though, I'm sorry, this truck that I
Right.
had yesterday had been to
Mhm.
three shops, and
Really?
all it was inertia switch, and
Wow.
it's like really, so it kind of tells you what I've been screaming at about electrical testing and understand wiring diagrams. So it's
Yeah,
sad
yeah,
that they couldn't
exactly.
fix this simple problem. It's like
Exactly. So we're talking about oil. Do you recommend everybody uses the Ford engine oil in a 6.0, or can there be other substitutes?
There is the WSS certification now from Ford,
Hmm.
and that is actually applied by, in other words, that is used by many oil companies. So if you actually do a Google search on Ford WSS engine approved, they have a list of approved oils.
Okay.
And I'm a big Valvoline Premium Blue user in the past. And guess what? It's not on the list of 50 to
Really?
40s. So therefore, it's not a list of approved oils. Now, I called AutoZone here, not to endorse AutoZone, but in this case, I said, hey, send me your cheapest oil. I did that as an experiment. And in this case, I found out that the STP oil that I got is endorsed and certified by Ford. It's got the WSS certification. It's got the Detroit Mac and all these different certifications. So believe it or not, that cheap oil that they sell usually every week on sale is not bad oil. So, so if you're one of
Sure.
those Rotella guys that like to use a quality oil, you go ahead, but just it is on the list. I know Rotella is on the list, but be aware of that. So
All right. Very good. I think that about covers all the questions we have on here. So once again, Tony, thank you very much for an excellent presentation, and thank you all for attending this webinar today. And like I asked earlier on, please give us some feedback as to what you would like in the future. Like that, we know that we can, tailor make something that fits your needs. So without further ado, we'll see you again in September for
God
another
bless.
sponsored by Lucas Diesel Systems. Thank you very much. Bye, everybody.